Hello and welcome back. So now in this lecture we will work on our main camera controller. Okay, for that right here in the scripts, go ahead and create a new mono behavior script. You can name this as car camera controller. Then click on the main camera and drag and drop this script right here. Actually this one, car camera controller. Okay, then after that let's open this up in Visual Studio. We're gonna remove the start and update method, and at the top we will say public transform, and the transform will be an array because as you know that we will be having more than one cars. Okay, total we will be adding 3 cars in this game, or if you want you can extend it to even more cars. So the reason we will be needing this transform array is because we want to follow each car whenever that car is active. Okay, so that's why we need a reference to all of the cars. That's why we make the transform an array. Then after this, we will create a public vector3, name this as offset. This will be equals to new vector3, and we're gonna set up the offset right here. So for the x it will be 0, for the y the offset will be 1.2, and for the z the offset will be -10. Okay, after this we're gonna create a public float by the name of follow smooth speed, and the follow smooth speed will be 0 by default. And guys, make sure that right here you add f at the end because this is a float value. Okay, then after this what we're gonna do is we're gonna create a public float by the name of mouse sensitivity, which will be equals to 500 by default. Then create a public float by the name of rotation smooth speed, which will be 0. Then what we're gonna do, we're gonna create a float by the name of minimum vertical angle. It will be equals to, let's just say, -6. Okay, this will be the minimum vertical angle to prevent going underground. Okay, so that the camera doesn't go underground. Then make another float by the name of maximum vertical angle, and this will be 60 by default. Okay, this will be the maximum vertical angle for the camera. After this, create a private transform reference to the active car. As I told you, we will be having 3 cars, so whatever car that is active, we're gonna follow that car. Okay, so we're gonna store that car in this transform. Okay, this will store the currently active car. Then create a private vector3 by the name of current offset, then another private vector3 by the name of current velocity, and then a private vector3 again by the name of rotation velocity. Okay, then a private vector2 this time, and this will be by the name of mouse delta. Now after this, when the game starts, what we're gonna do, we're gonna initialize the offset to the default. So current offset will be equals to the offset Then we're gonna lock and hide the cursor. So in order to do that, we will say cursor dot lock state equals to cursor lock mode dot locked. Okay, and then we will say cursor dot visible will be equals to false. Now in order to find the active car, okay, or the player current car, we're gonna create a method right here, and that method will be of type transform. Name this as find active car. In here we will first of all check each car in the array to see if it's active. In order to do that, we will create a for each method, and then we will say transform car in cars. Then we're gonna return the car. Alright, but we will only return that car which is active in the cars array. So for that we will say if car.gameObject.activeSelf. Then in this case only we will return that car. Okay, so just simply now type return car. Then we will return null if no car is active. So in order to do that, right outside the for each, just simply say return null. After this, we want the camera to follow the car. For that, create a method by the name of follow car. In this, first of all, we will smoothly follow the active car with the current offset. So we will say vector3 desired position, it will be equals to active car dot position plus the current offset. Okay, then transform dot position will be equals to the vector3 dot smooth temp. In here pass the current position of the camera, then the desired position, and then we will pass the current velocity, and then we're gonna pass the follow smooth speed. Okay, then we will make sure that the camera always look at the car. So we will say transform dot look at, and we want to look at the active car, so we will say active car dot position plus vector3 dot up, multiply that by 1.5, and this will slightly set the camera above the car position. Okay, now once we are following the car, of course, in all of the parking games the player can rotate the camera manually in order to see the obstacle around the car. So in order to add rotation, we're going to create another method now, and this method name will be handle mouse rotation. In here we will first of all get the mouse inputs and store it inside this float mouse x and mouse x and mouse y. Okay, so first of all let's do the mouse x. Right here we will say input dot get axis. We want to get the mouse x, multiply that by the mouse sensitivity, and multiply that by time dot delta time. Copy it till this point and move down, paste it, and now instead of mouse X we will say mouse Y, and everything else will be the same, but in the start we need to add the minus sign. Okay, then we will say mouse delta plus equals to new vector 2, pass the mouse X and then the mouse Y. Alright, now let's limit the vertical rotation to stay within the defined angles. So in order to do that, we will say mouse delta dot Y equals to mathf dot clamp, pass the mouse delta dot Y, and then for the X we're gonna pass the minimum vertical angle, and for the Z we're gonna pass the maximum vertical angle. Then we need to calculate the target rotation based on clamped mouse inputs. So we will say quaternion target rotation, it will be equals to quaternion dot Euler. Now right here we're gonna pass mouse delta dot Y, then right here we're gonna pass mouse delta dot X, and then the Z will be left as 0. Then let's update the current offset with the smooth rotation. So we will say current offset equals to vector 3 dot smooth temp, pass the current offset, then the target rotation, multiply that by the offset, and then we will pass the rotation velocity and the rotation smooth speed to it. Right, now let's move up right here. After the start method, let's add the late update method. In here, first of all, we need to find the currently active car. So active car will be equals to find active car method. Then we will check if the active car is not null. Then we will just simply return. Then let's call the follow car method and then the handle mouse rotation method. Okay, right here make this T capital, transform car in cars. Then get back right here, click on main camera. In here we need to provide the cars. For now we just have one, so I'm gonna drag and drop this classic car full in there. Okay, then the offset is already set up, and you can actually leave the other values as it is. Okay, and after that you can go ahead and play the game. And now you will notice that if you click on the game view, it doesn't follow the car, and that is due to, I think, this right here. Make sure it is equals to null, okay, not equals to null. Once you do that and get back to Unity and then play the game, you will notice that now the camera is following the car. Now if you see the car tires, as you can see, they are rotating, and as you can see, it works perfectly fine. Okay, we can now rotate the camera as well for the car. All right, and let me tell you that you can set up your minimum vertical angle to a lesser value if your camera is going inside the ground. Okay, for me -6 and 60 works perfectly fine, as you can see, but If you are using some other environment or your camera is going inside the ground, then make sure that you change this minimum and maximum vertical angle to a value which you like. Okay, now our car controller is done and we have the camera controller as well. In the next video we're gonna work on our missions. Okay, we will add obstacles in which if the car interacts we will fail the mission, and if the player parks the car in the position which we want, then we will pass the mission. Okay, so from the next video onwards we will be doing that. So see you guys in the next one.